My name is Marc Martina. Everybody, I'd like to thank you for your time today. My name is Marc Martina. With me, I have Mason David. And our goal today is to review IBM versus AWS when it comes to data science. Data science is a big topic now, machine learning, predictive analytics, not just determining what has happened, but what is going to happen. And we wanted to really compare what the products are like out there. So we decided to pick IBM's and AWS's version. So let's start off. So our goal today is we're going to start off with a few slides, just kind of give you a high-level overview of some things, and then we're going to dive into the products themselves so you can actually visually see and compare the difference when it comes to features, functionality, and usability. So we're starting off a little bit with the standard kind of Gartner quadrant, Forrester Wave, another one in here called IDC MarketScape. So if you see on here, IBM seems to be a leader in pretty much all of them. So in Gartner quadrant, they're top right. AWS is in visionaries category versus the leaders. If we're in Forrester Wave, honestly, I don't see AWS on here at all, and IBM is top. And then if we're in the MarketScape one, IBM is obviously in here, large circle. AWS is here as well. Decent sized circle and kind of close to IBM, in my opinion, probably closer than it should be. But AWS is very strong in the market for infrastructure and cloud, so we thought they'd be a good compare. Here's another thing we have as well. Gartner had critical capabilities report. If we take a look in here, AWS is on it, but obviously not the top. So the top in everything is pretty much IBM, and then after that, things kind of bounce back and forth a little bit, depending on, I guess, what their use cases were, how they were testing things out. So IBM's product is what's called Watson Studio. What's nice about it is it's on the cloud or on-prem. So IBM tries to keep everything what they call hybrid. So you can purchase the software, install it on your own servers, or you can spin up a cloud instance of it. We're going to be showing you the cloud instance of it because it's probably more of a fair compare, cloud versus cloud with AWS. Watson Studio has a ton of different features. Automate the AI lifecycle for model ops, build and scale trusted AI in minutes, accelerates time to value. So automated AI is something that's kind of built into Watson. You're going to see that there's a big difference between Watson and AWS when it comes to automation of the tasks and actually the web interface. One's definitely more GUI based than the other. Model monitoring is actually very important as well, and that's actually part of Watson Studio. Easy to use. What you can do is you can actually just get a trial, which is great. You can also do the same, I believe, with AWS. So that's the benefit of the cloud. So if you want to take a look, play around with this later on, you can just go to the IBM website, the AWS website, create a free account, kind of upload some type of flat file or connect to maybe a data source and just start playing around right away. Watson Studio has a large partner ecosystem. No query engine with Apache Hadoop. No single or simplified installation. So let's kind of continue. And then on the AWS side, we have SageMaker. So SageMaker is the equivalent of Watson Studio. So AWS is obviously a market leader when it comes to infrastructure. SageMaker is gaining increased share from AWS with machine learning workloads. And I think the reason is that a lot of people are on AWS from an infrastructure point of view. And so all they do is they just click here, click there, and all of a sudden now they have SageMaker going and they can integrate it with what they're currently using. Versus if they're on there and they want to use a different product, whether it's IBM's or someone else's, it's more of an acquisition, more involved versus just here it is. Right. And some of the things that are pro and cons, right? So it's public cloud only. So you have to be like an AWS member to actually use it. You have to log into AWS, connect to it. IBM, it's on IBM's cloud. Then you could actually install it on other clouds if you want to, or on-prem. So that's definitely one of the big differences. And there's definitely limits in the capabilities, and we'll kind of go through that as well. So rather than continue with this, I'm actually going to go right to the product. So again, everything's web-based, so you can use a browser. Right now, I'm actually logged into IBM's version, which is Watson Studio. It supports all your main browsers: Chrome, Safari, Edge, Firefox. I'm using Chrome, so I'm a Chrome person. And if you see I'm logged in already, I'm logged as Mason because I'm actually using his account. So it's welcome Mason. One thing that you'll notice right away is it says IBM Cloud Pak for Data. So it doesn't say Watson Studio. So what IBM has done is they've taken all of their data and AI components and they put it into one platform, and that's called Cloud Pak for Data. It's available on-prem or in the cloud. A few variations depending on whether you're going with the cloud version or not. But it's designed to literally be a one-stop shop for everything. It's like the data fabric solution for everything involving data. So ETL, databases for data warehousing, governance, analytics, dashboards, pretty reports, and things like Watson Studio with AI and machine learning built into it. We're going to really just kind of stick with the AI ML stuff for now. But if you click on the little hamburger in the top left, you'll see that there's a variety of different things you can do. They don't name it by product, but by category. So there's things like governance, different services that are available. We don't have them in here, but there'd be databases and all these other options that you can do. Right? So sticking here, this is the dashboard that you come into. It's customizable as well. But what I'm going to do is I'm going to actually start off with one of the projects. So everything's organized with projects. So if I click on the insurance classification, this is going to take me into the project section. And this is essentially the start for Watson Studio. So on the left here, it's kind of where we want to start off. So these are all your different assets. So things that you're using, in your AI machine learning journey. Right. So we can start off with data. Data is exactly what it sounds like. It's the data I'm using. To do my analysis. It could be flat files. It could be database connections. It could be a variety of different sources, individually or together. If I want to create a brand new asset, I can do that. It gives me all my different options. A lot of times what you'll end up using is you'll go to a connection, and then you'll actually select the appropriate connection and connect. As you can see, it pretty much connects to everything. So these are built-in types. So if I want to connect to an S3 bucket, no problem. A database, whether it's Amazon's or Google's or IBM's DB2 or Oracle, it's all available to you. Also, things like ODBC drivers are available, JDBC drivers are available. So if you have something that's more generic as a connector, you can use that as well. So in this case, I already have an asset. I'm just going to use the CSV file, but obviously I can connect, upload more files, connect to more data sources without any problems. The next is flow. And for flow, there's two different things. There's SPSS modeler and pipeline. I'm not sure if you're familiar with SPSS modeler or not. It's been around since the beginning of time. It's kind of been like the de facto standard for things like statistics, predictive analytics, especially in schools. So if you're taking a stats class, usually you'll be using SPSS statistics. So modeler, what IBM has done with their acquisition is they've obviously improved it over the years, added features to it, but they've also completely web-based it. So now modeler is available, and it's exactly the same as the desktop version, but now it's in the cloud. I can just click on here. There's my modeler package I have, and if I want to open it up, I might actually have it open already. Here's that model. So if you're familiar with SPSS modeler, this is pretty much the exact thing in a web version. Instead of having all your little nuggets at the bottom, it's over to the side, but you can import your data, your different record ops, and then you would just drag and drop things over just like you would normally in modeler. So that's actually part of Watson Studio. It's part of the experience. So if you wanted to do all your predictive analytics in modeler and you want to do it in a cloud-based interface, so it's easier for people to just log on with a browser, you can do that. So anything that's available in modeler is now available in Watson Studio with a web interface. We go back to it. The next is pipeline. And I can kind of show you maybe a little bit of pipeline if I want to create a new one. Pipeline is essentially going to be, it's going to be a flow diagram, essentially. So if you create something amazing and you want to kind of automate it, you want to have the flow going where creating a data file, I'm running, AutoAI, I'm doing some updates and moving things around. This is essentially, your job that you're creating. So it's a pipeline. So it's the actual flow chart of the data, the algorithms, the output, the action that's done. And again, it's all web-based, all very simple, all very easy. Go back. Next, I've got my experiments. And I've got a few AutoAI experiments. And what AutoAI is great. So Mason's more of a data scientist. He's very good with Python, R, Scala, coding languages, things like that. I'm personally not. So AutoAI is IBM's easy to use web interface for doing complex statistics without actually having that statistical background. Right? So we've got a few here right now. Right? And I can actually come in and create a new one as well if I wanted to. So if I wanted to come in, create a new one, I can create a new AutoAI. Right? What am I doing? Well, it's Moxie machine learning. What am I going to call it? AutoAI. The environment, so our environment is set up with 8 cores, 32 gigs of RAM, which is great. If we have multiple options, we have multiple options here as well. And I hit create. And now here, it's just, all right, what's your data source? Well, I can browse for them or I can select it from the project. So what's nice is data sources are in the project, but somebody who's an administrator can create them for the entire ecosystem. So all of Cloud Pak for Data can have certain data sources. So you don't have to be, a data scientist or understanding databases, how to connect to things like that. Somebody can preset those up, assign permissions to it. So I'm allowed to access data source 1, 2, 4, and then somebody else is allowed to access the other ones. So it's for data sets, got like my medical insurance. I hit select. All right, is it a time series? No. What do you want to predict? I can actually select what I want to predict. In this case, it gives me all my different options based on the input file. I'm going to say insurance claims. Then I've got different settings. So it's binary classification, either going to have a claim, not have a claim. There's different algorithms. Algorithms to use, 2 out of 4. I'm going to make it just 1 out of 4. This way it'll be a little bit quicker. I'd say this model runs in probably about 2 minutes. And if I want, I can just come over here, run my experiment, and now it kicks off. So as you can see, no code, no anything. I used a flat file for a data source. I could have used a database, could have used multiple databases. If I wanted to, instead of using AutoAI, I could have done things using Modeler. In this case, I decided to go with AutoAI because it's simpler, it's easier, and it literally does everything automatically for me. Right? So it's reading my data source now. And if it's something that's quick, you can literally stay here and kind of watch it as it progresses. Right? So elapsed time is about 32 seconds. It's got a progress map here. So it's actually going to go through each step. The relationship map is constantly changing. So now it's gotten from step 1 where it's reading the file and step 2. And so what it's doing is it's using 90% of your data to train, and 10% as the holdout data. So after it trains it, it's going to test it on the 10% that's remaining. Now it's selecting your different algorithms. We saw the list of algorithms that were in there. So what it does, it's going to use all the algorithms that apply and then pick the ones that are appropriate. There's pipeline 1, pipeline 2. We selected up to 4 pipelines. So it's going through the 4 different pipelines, running the algorithms, coming back with the results. And again, no code, no fancy functions, algorithms under the covers that I have to know, understand how to use, even know the name of. Now it's finishing up. And there we go. Right, so there's 4 different pipelines, so 4 different runs. It actually did enhancements, the 3 out of the 4. And it gives you, so feature engineering. So it tells you the enhancements it did. What's an enhancement? Well, essentially, it might take your data and change it in order to not change the actual values of the data, but to give it something that's more usable and gives you a better actual result. So in this case, without changing anything, it came in 3rd place, but the 1st place was pipeline. I can click on it. Right, here's my model evaluation. Holdout score, cross-validation score, accuracy. Right, so it's 95.5% accurate. Something called a confusion matrix. So if you're really strong with math, statistics, this should all be pretty commonplace for you. Right. But take a look at the feature summary. So remember before it said it created calculations for you? Well, here they are. So based on what I was looking for, children was the #1 factor. But then it also did some sums of different values. And so it actually created other columns of data that didn't exist before for importance. And then if I want, I can save it, or I can just, if I don't like it, I can just X out. So this is what AutoAI is. So this is a great way of creating things, algorithms without actually knowing any of this. I can also save my code. So if I want to save the code, I can do that too. And if I do save it, I can save it as a workbook as well, if I wanted to. So Jupyter Notebooks. So now I'm saving it as a notebook. So this is the actual notebook, and see that in the end, it turns everything in the code, which to me is a little complicated. But this is literally the code that's being run. If I go back, so if I do save code, the code will be saved here. And then the models are actually here. And so this is the interface you use for Watson Studio to generate all your machine learning. One of the other things I'd like to show you is another service that's kind of part of this. If I go into service instances, and there's something called OpenScale. And what Watson OpenScale does is it essentially checks your model. So if you create a model and it works beautiful today, it might not work so well tomorrow, right? Over time, your data changes, situations change. And so your model kind of loses its validity over time. And what this does is it's able to actually take a look at your model and actually scan it, check it, and make sure that it's staying on track and actually automatically adjust it if needed. This one's a credit risk. And what it does is it looks for fairness, quality, drift. Right? What's nice is everything is well documented. So if I want to, tweak something, I can click on my different options. It tells me what fairness is. It actually gives the definition of it. So it checks for bias, tracks when the model shows a tendency to provide a favorable outcome more often than not. Right? And so here's all my different settings. Here's things as monitoring. If I think it's good, great. If I don't think so, I can just hit edit and I can change it as well. Monitored, reference. And so I can constantly change all my different settings. And then I would run this daily, probably weekly, and it'll actually check my model to make sure that everything's correct. that I'm not having any problems, no skews. Everything's still on track.
Yep. And just to add on to that, you can also add alerts. So while your model's running with your endpoint, you have a prediction. Your predictions are coming. Your data's coming through. It's your model that's scheduled has a prediction. It outputs it. This is monitoring it live for you. So if your model's working as it should, then you're fine. But if the data is not the same, maybe we have some bias in some of our features, then at the end of the day, this will alert however you want to configure it, but we would configure it to alert you, say, hey, your model's not performing well, maybe we need to adjust some things. So however the business use case is set up, it can handle it. It's configurable.
Excellent. So this is just kind of a high-level overview of Watson, how it works, usability, the interface, give you a feel for it. Mason, you want to take over now and maybe show the AWS equivalent?
Sure.
All right, I'm going to stop sharing. Great.
Can you guys see my screen?
Yep, I can see it. Amazon SageMaker Studio. Perfect.
Okay. So the difference between AWS and IBM, the big difference is mostly just the UI. AWS is great in infrastructure, but they've just been a little bit behind on the data science side. It's still a good product. As you can see, IBM is just a little bit further, and it's simply because IBM has the UI, has the model monitoring, has the pipeline, which can automate, training of your data, connecting your data, training it, automate if your data is drifting, re-updating the model, doing different things. You can automate that process. You can do that in AWS, but it's strictly code-based for the most part. They are starting to get better with giving you a new UI, and as you can see, so this looks and feels like what's called Jupyter Lab or Jupyter Notebook. And so basically, if we wanted to create the same thing what we just saw in IBM, you would do that by you would jump into your notebook. And so with that being said, I'm just grabbing some data, some sample data that they already have. I download it, set it into a file system like we would, or a more experienced data scientist would in their own environment. I can view the data. I split the data. So I have my training and my test data. And you can see I have that over here as well. And then when you jump into it, I can actually create an experiment, which is I just go here and under File and New Experiment, you get this tab right here. I already set the things in there for you, but basically we name our experiment. This is the equivalent to basically AutoAI. And so it looks, the S3 bucket is our data location. So all that's configured for me, checked it all off. I'm setting my target. That's what we're trying to predict. So that's churn in this use case. Obviously they have extra settings, which is configurable. So someone who isn't a data scientist or has the experience of writing Python or they can go through here and check these things off, how we're going to measure it or do it by accuracy. And as you can see, we can just set different parameters to control security. So this is a little bit different. Security can be a little bit more configurable. This is notebook-based or experiment-based versus IBM is gives you at different levels. But so once I run this experiment, basically I get this output right here. This output kind of shows all the models it generated, and this is configurable as well, how many it generates, show you the job profile, and what time it took, things of that nature. But from here, we can actually look at model details, which I'm gonna go through, open the candidate generation notebook and the data exploration notebook. It's gonna show you kind of some of that feature engineering that IBM, similar to IBM was doing, it does as well. So here we're looking at a multi-layer perceptron model, which is a neural network. And here's our metrics to measure how our model's doing, the parameters it used, the number of layers, the activation function. So like all the stuff that a normal data scientist may configure on their own if they were to write their own model or algorithm. This kind of does it for you in a similar fashion that IBM does. This is their comparison product. So once I can deploy it, which we're not going to do that here, simply set up deploy. It would give me API access. It would give me the credentials. From that perspective, it's still code based though. We still have to map it out, build out the process in a file infrastructure to manage that kind of pipeline. So in my opinion, it's not automated to the degree that IBM is, simply because in IBM we have a UI to do it. It's clean, things are integrated. This is a little bit different. So from here, we can view the exploration, which it did under the covers, autopilot. We can look at our data, see some of the things they went through. So the target analysis, how is our split on our target variable? Let's see what else. We have our data sample, checking for duplicate rows. We look for correlations. That helps us do some of feature engineering. So this is doing it all under the covers, very similar to IBM. It's just in a different context, a different UI, different feel. The benefit of this is you can get advanced, but you can also do that with IBM in notebooks as well. With the UI that they do provide, it allows the end user from kind of any level of experience to work and build their own models. You have SPSS Modeler, which does auto algorithms as well. So they could do that, build out a workflow from that perspective, or use AutoAI pipelines. But from this perspective, you really kind of have to be a data scientist. It does a lot of it for you. So you would have to build some skills to do it if you weren't a true data scientist or a coder. So this gets into the candidate definition, some of the things it did to clean the data as well, some of the configurations it set. So it talks about how some more vectorization for the text as well, standard Scala to scale the data, all feature engineering stuff, right? It's using XGBoost as the model in this use case, but basically it's all code based, as you can see. If I wanted to monitor the model in a similar way, they do have a monitoring service, but you have to configure it as well with code. So at this point, I would configure it, build a job using the different scripts, and from that point, you can build it out in a fashion, but it's still manual. It's still the traditional way. But like I said, AWS has definitely picked it up a little bit with creating the autopilot. So they're moving in the right direction. They're just still a little bit behind, which warrants kind of the Forrester and the Gartner's opinion of IBM being top in the space. So that's pretty much it.
Yep. Thanks, Mason. Appreciate it.
Yep.
Yeah. So I think that's pretty much our overall assessment. I think AWS has a lot of people, on their platform who just, who'd use it, SageMaker, because it's there. But when it comes to usability, unless you're very strong with coding, it's not really a usable product. Versus, the IBM side, if you're not good at coding at all, you don't have a data science background, you can easily use it. So I think the audience is a lot greater. So if somebody wants to dabble with something, figure some things out on their own, play with things a little bit, Watson Studio allows that very easily. You don't have to have all that coding background. Then when it comes to the actual, data scientists, I think they could probably get away with either product, but I just think it's going to be a lot more challenging for them. Because in my experience, somebody with a strong data science background usually doesn't have a strong background with things like data. So pulling in data is sometimes a challenge, and Watson Studio takes that away from you. It makes it very simple. Somebody else can create the data connection for you. There's no coding involved. You just bring it in. It's easy to connect the data, move the data around, versus just coding everything every time. Maybe once you get started and you're into it a while, it'll be okay. But I think it's going to take you a long time to kind of get there. When it comes to pricing, I don't think we really did a lot of evaluation on the pricing. It's kind of a challenge to do. My thought is if it's not, IBM should be more expensive, just because they bring so much more to the table. But I'm not really sure what the pricing is. There's definitely different options with IBM because you can actually buy the product and install it on-prem or use the cloud version. So it's hard to kind of do a one-to-one compare on pricing when one is just cloud and the other one is either cloud or bring your own license.
Great. And everyone, this recording is going to be available after the session. We'll send it out via email. I know we got a lot of emails from people who had conflicts but were interested in it. If you or any of your colleagues are interested in the recording, we will be sending it out within the next couple of days.
If there's any direct questions, feel free to ask those at any time or email us and we'll get back to you very quickly.
Thanks everyone for attending.
Thanks, appreciate it.